Welcome everyone, welcome to our talk. This is the first time that we're presenting this talk and presenting together these two topics, and we're going to talk about abusing GitHub for fun and profit, talking about actions and Codespaces security. So I did the research around GitHub Actions and he did the research on Codespaces, and we're going to talk together here about these two topics related to GitHub. My name is Magno Logan and this is Nitesh. We work for Trend Micro. So just a little bit of introduction about myself. I'm originally from Brazil. I've been in Canada for 5 years now. I practice martial arts and I'm part of the Nebula team. This is our threat research team inside Trend Micro. We focus on cloud and container security. I also have a blog called Katana Security. I'm an instructor for Go Hacking. It's a cybersecurity company back in Brazil. The best way to reach out to me is through LinkedIn. So this is the QR code. I promise there is no malware there. And yeah, I'll hand it over to Nitesh to introduce himself.
So my name is Nitesh and I work in Trend Micro. We're in the same team. We're called Nebula. And I'm a senior threat researcher with 2 years of experience. And professionally, I've been working for 3 years now. And so previously, I have worked in a security operations center where I have performed threat intelligence, threat hunting, so working on ransomware cases. And previously, I have started liking to break things. So I've reported bugs in Android apps with over 21 million plus downloads. I've reported security issues to the US Department of Defense. And I've broken my home router and found some bugs there as well. So I had this knack of things, and then I joined Trend Micro. So in Trend Micro, we work on specifically cloud-native security. So like we try to find out vulnerabilities, threat models, issues with the tech that you guys are using. And we do that before the bad guys do. So that's how we build detections. We find novel ways of exploiting some sort of vulnerability. And yeah, so I'm also a member of the null open security community. So it's a community like OWASP where we generally discuss about how to break and how to fix things. So we do that for free, and like it's all over the world. You can take a look. I'm also a beginner vocalist and guitarist, so I know that there is a good music scene in Oslo. So like maybe we can hang out sometime soon. And that's my link tree and the QR, so we can connect there. Yep.
Sounds good. Awesome. So this is the agenda for today. We're going to start with Codespaces. We're going to talk about some of the features there, how it works if you haven't used it, and then a real-world abuse, something that we published earlier this year, and now attackers are also exploiting that already. And of course, at the end, we have some recommendations. If you're just if you're a developer, if you're working for a company that it's using Codespaces, then you're going to learn more about how to protect yourself and your environments. And then we're going to cover GitHub Actions, abusing runners, so how attackers are exploiting those VMs that basically run on Azure to mine cryptocurrencies. Also understand the idea of third-party GitHub Actions. Malicious, anyone can publish actions to the marketplace, and some malicious actions can be there as well. And of course, again, some protections, some countermeasures to prevent yourself from any attacks. So I'll let Nitesh start with his part.
Thank you, Magno. So let me tell you a story to begin with. Back in 2021, on one of our honeypots that we had exposed publicly, we got an exploitation attempt where there was an attempt to exploit various vulnerabilities in well-known applications like Apache HTTP server, Oracle WebLogic server, where the attackers were abusing GitHub and Netlify to host their crypto miners. So they would just download the crypto miners from GitHub or Netlify, and they would execute that in the victim environment. So in this blog mention, we discuss about the details. So the crypto miners actually target Windows and Linux environments both. Since we all believe in PCAPs or it did not happen, so here we see an attempt to exploit a vulnerability which is known as Apache HTTP server remote code execution vulnerability. And in the body of this post request, we see the header set to raw.gitubusercontent.com. So basically, this downloads a shell script from the GitHub CDN and executes this on the victim's environment, which in turn downloads a crypto miner and mines cryptocurrency. So the infection chain of this entire thing was as follows. So the attacker exploits a vulnerability on a vulnerable service, and then there is communication with GitHub or Netlify via HTTPS. And since these are generally trusted domains for IT organizations, this would not trigger generic tools to detect all of this abuse. And once it downloads the malware from GitHub, it executes on the vulnerable host and it hijacks compute resources to mine cryptocurrency. So this was the general flow of the entire thing. So the reason behind showing this is a very straightforward story that has been observed time and again, where GitHub is being used to host malware and attackers download it from there, and it does not get flagged by antivirus vendors. So with this story in mind, when attackers are actually using the platform, abusing the platform, we take a look into Codespaces. So how many of us have used Codespaces before or have heard of it? Just a show of hands. Okay, thank you. So Codespaces are basically fully featured cloud-based development environments, which comes with a lot of tools, libraries bundled within the environment. It is basically a development environment is a Docker container in which you find all your tools existing. So you can create virtual machines of like different configurations, like the RAM, the CPU, the storage can be different for all of the virtual machines. So these are isolated virtual machines hosted on Azure cloud. And these were like made available for the users, for all GitHub free users on 9th of November 2022. So it enables coding from anywhere. You just need a browser or the VS Code IDE or the GitHub CLI to access the Codespace environment. And it also lowers the barrier for folks to get into software development, because it is free and you can create up to 2 running Codespace instances at the same time. You get 60 hours of, 120 core hours, but with the minimum core is like 2. So you have 60 hours per month that you can use in Codespaces for free. And yeah, so additionally, any user with a valid GitHub account can create 2 virtual machines on Azure cloud for free. So the maximum duration for that virtual machine, like the default idle timeout, the maximum time can be set to 240 minutes. So that means when you create a Codespace instance, and if you just leave it running, you can have the Codespace up for 4 hours if you have like modified the default from 30 minutes to 240 minutes. And the retention period for Codespaces is 30 days, like the default and the maximum value. So what that means is if you stop a Codespace, it will be deleted after 30 days of inactivity. So with these pointers in mind, let's think like this. Since any user with a valid GitHub account, they can create a Codespace instance. What could a user with malicious intents do? So previous instances of abuse of GitHub have been observed. Like we saw the abuse where cryptocurrency miners are downloaded from GitHub, GitHub Actions, like the stuff that Magno has done before. The idea was how long would it take for attackers to actually abuse Codespaces? So we started to look into it before them, probably. And so we put on our hats and started looking into this Codespaces feature from an attacker's point of view. So Codespaces has a feature in which you can expose a port on the virtual machine, on the container, and then the virtual machine, and then to the internet. So this is a very helpful feature for developers because you are working on your code, you want to test or debug, how does your application look? You can just expose the port and you can access it. So the ports on a Codespace, they can be forwarded in 3 ways: private to the organization, and public. So private, so when you forward a port privately, so you can access the port all by yourself. Private to the organization, anybody in your GitHub organization can access the port on the Codespace, provided they have the full URL. And public is accessible to anyone without any authentication. They just need to know the entire URL. So we created a code space based on the blank template, and we start a Python-based HTTP server. So once we start the Python-based HTTP server, we get this prompt, like your application is running on port 8080, and what do you want to do with it, something like that. So when you forward a port on a code space, by default, the visibility of the port is set to private, which is a good thing. Like only you should be able to access the port that you are trying to expose, right? And unless and until one deliberately changes the port's visibility from private to public, they cannot access the code space, like the port. So if you notice the URL looks like we have the username of the GitHub user, like that's idea engine 007. That is followed by the name of the code space, that is turbo space orbit. And this is followed by a random ID. And then you have the port followed by .preview.app.github.dev. So let's access this URL from our browser and a terminal as well. So we have modified the port visibility to public. So we see that there are no cookies being used, and there are no redirects being observed. And we can access the port on the code space by knowing the URL. So this bit is important. I'll explain why this bit is important a bit later on. And yeah, so if you see, when you have just created a Python-based HTTP server, on the browser it looks like directory listing for the directory, and then you have a bunch of files there. And I'm doing the same thing using curl, so that how does it look on the CLI as well. So, so far, do you have any questions? We're just exposing a port publicly on a GitHub code space that you have just created and setting the visibility of the port to public. OK, I see none, so I'll just proceed. So before moving on, have you heard of open directories? Anybody from the audience? OK, so I'll just explain. So open directories are basically publicly accessible web servers. And they have content that can be downloaded by anyone. And this is one of the most popular ways used by attackers to host their malware. They just take an IP address. They will create an Apache HTTP server or something, and they will just list down the stuff that they want to use later on. And this is widely used to perform malware delivery. So the malware can range from like ransomware to you can have exploits, and you can also disclose data in the form of open directories. So, yeah, so you can, the attackers have been observed to do all of this. And previously, we just exposed a port on a code space manually by setting the port's visibility to public, right? So let's take a look at this. How would attackers be able to automate creation of file servers, or let's say malicious file servers, using GitHub Codespaces? So, yesterday there was a very nice talk on dev containers. So have you guys attended it? OK, have you heard of dev containers? OK, cool. So now the thing is, OK. So dev containers, so you can say that you want to create your environment. So it's basically configuration as code. So you can specify the various components of your environments, like the features, the ports you want to expose, the name of, the container image that you want to use in your dev container, and then it's all specified in a JSON C file. So JSON C is basically JSON with comments. And yeah, so the environment is as a JSON C file, and the developer's environment can be local or remote. So local is like your laptop, and remote is like your code spaces. So it has also some powerful primitives of command execution. So here's one example, which is called post start command. So when you specify something in the post start command in that dev container configuration, the command is run whenever the container is started. So this is the link for the specification of the containers.dev. So basically, they have this entire JSON reference of how you can create your dev containers. And while just doing a quick search on GitHub, like how many folks actually use dev containers, So we have a search query here where we are looking for all the paths that contain this file, devcontainer.json, and we have like 33.4K hits. And there is a VS Code extension that is just made for dev containers. It was previously called remote containers, and it has over like 14 million downloads, 1.4 million downloads. Okay. So in this case, the idea is that how can the attacker create malicious file servers with automation. So in this case, we see the dev container configuration that is described in this hidden directory, .dev container, and then this file, where the dev container is named Ubuntu. It is created based on an image, like the container image. The Docker image for this is maintained by Microsoft, and the port 8000 is exposed on the code space if you create from this dev container. And once the container is created, when the container is started, we have this post start command directive, which basically creates a Python-based HTTP server listening on port 8000. I'm not sure if this is visible at the back, but okay. So, yeah. So here we have the attacker's dev container configuration. And let's imagine a scenario where the attacker is already there in the victim's environment, and they want to download some sort of malicious file on the victim's environment by they are basically trying to bypass the standard detections that are there. Okay, so from the attacker-controlled code space based on this configuration, the attacker can request some malware from some other website, and then they can just publicly expose the port. The domain, the URL will have this format like preview.app.github.dev, and this will be delivered over HTTPS into the victim's environment. So this is a simple script to create GitHub Codespaces based open directories, which will be live for 100 seconds. So this assumes that the attacker is already authenticated into their account using the GitHub CLI. So first we create a code space based on this remote repository, which is the username is Adititli, and the name of the repository is Adititli based on a basic Linux 32 GB code space VM. So once this VM is created, can I call it a VM? So it's a container which is inside of a VM, but the port is exposed on the VM as well. So yeah. So the first command that you specify to this script executes the command in that code space that is just created. And later on, we just expose the forward the port to public, and then you have the entire URL where you can access the code space, like the port that you have just exposed. And then it just sleeps for 100 seconds and deletes all the code space. This was just a simple POC to show how trivial it is to automate. Oh, sorry. Okay. Oh, no. Okay, so this was something that, not this. Yeah, this was something that we did back in January this year, where we were talking about how these cloud-based IDs can be abused, since you can create code spaces for free. Later on, based on threat hunting and some information from security researchers on Twitter, there was code spaces have been observed to be abused by infostealer malware. So do you know about infostealers? Okay, let me tell you. So infostealers are basically malicious programs that can exfiltrate browser cookies, passwords, credit card information, Steam data, Discord tokens, the cold wallet, cryptocurrency wallet keys, and some user information. Once all of this executes, the infostealer executes on your environment. Okay, so all of this is packed and sent to some sort of webhook that belongs to the attacker. So in this case, the webhook was Codespace. And this is something that we found over threat hunting as well. And in this case, the information is being sent, and we had already predicted that this abuse can happen. And this sample that we looked into, it was written in Rust-lang, so that would have actually evaded a lot of, it had anti-debug capabilities as well. So if you want to figure out how does this sample work, your normal tools would not work. Like if you want to reverse it via IDA, they won't work in the same way. So it didn't take attackers a long time to begin abusing this very cool service. And this is one sample which was detected on, which was not detected on VirusTotal, but this is an info stealer which is exfiltrating all of that stuff that I just showed you to a code space, to an exposed port on a code space. So it has 0 detections, so that means it was not detected by the AV vendors. And this is the URL where so this is the URL where the information was being exfiltrated to. This is our article. If you want to learn more about what are the nitty-gritty details of the code space abuse that we found in January, this is the one. And this is the first part of the Rust-based info stealers that were abusing GitHub Codespaces. And this is the second part, where the info stealer also modifies the victim's Discord client itself. It modifies it in such a way that the user's credentials are logged and sent to the Codespace instance that is owned by the attacker. So with this, if you have any questions, I can take it now, or I'll just hand it over to Magno.
Sounds good. Thank you, Nitesh.
Okay.
Okay, let's move on. So now let's talk about GitHub Actions. We also have some blog posts there. Of course, there is not enough time for us to cover all the details here, but talking about exactly what are the runners, the VMs that you run your actions, and exactly what attackers are doing in a similar way using GitHub Actions to mine cryptocurrencies. So there's stuff there. But let's understand first how actions work. So who here uses GitHub Actions? Okay, good, nice. Okay, so basically it's a CI/CD tool, right? So you have it as a better way to maybe not run Jenkins, but in a way that you can run your automation. You can create your automation as code, and you have that code inside your repository, inside your application. And anytime there is an event that happens inside your repository, it triggers your workflow, it triggers your action. So this action will run by default inside a runner, and runners are basically VMs that are provided for you inside Azure, right? Since GitHub is owned by Microsoft, everything here runs on Azure. And those VMs, they're not spun up at this time. The VMs are like idle and waiting for an action to start for them to be assigned. So they start really fast. So one thing that I started when I was doing this research, like, okay, I thought these were containers because they were starting really fast, but no, they are there. They're just waiting for anyone to assign them a job. And the job is basically this set of actions. Actions can be either other actions, right? So you have your workflow, and your workflow can call other workflows, like could be like a plugin, let's call it this way right now. But it can also run scripts. And scripts, it's going to be either like shell script if you're running on a Linux environment, or a PowerShell, whatever, right? So here, the runners can have 3 different flavors. By default, the ones that are provided by GitHub are Windows, Linux, which is Ubuntu, and macOS. So you have all these VMs runners provided for you to run your automation. And same way with Codespace, it's free by default. Of course, there are some limits, but you can start right away with a free GitHub account. You can deploy this and run your automation. Same thing with Runner 2. They're just a representation. The way that it works, it's going to be another VM, and then you have another job. And the way that they're connected, it means something, right? So you see that Runner 1 is connected directly to Runner 2. It means that there is a dependency there. So Runner 2 is only going to start after Runner 1 completes in this way, in this diagram. So it means that the output of Runner 1 probably is the input of runner 2, so it needs to wait for this job. Yes, you can have them running in parallel if you want. That's not a problem. It's just the way that it's represented here. Okay, but where is this? Like, how do I do my automation? Where is this file, right? So GitHub Actions works as a YAML file. You create your workflow as a YAML file, and you store that file inside your repository, inside a specific directory called .github/workflows with an S, otherwise it won't work. So once you store there, if you are using the proper syntax, and the event is triggered, and an event can be like a pull request, any changes to the repository, a push, or you can manually trigger that event. So once that happens, GitHub will start your automation. So we'll deploy the VM, you run your actions, and then when your action is completed, the VM is completely deleted. You don't have access to that VM anymore. And anything that was generated, let's say you build a binary or you ran a scan, you need to upload that back to GitHub. Otherwise, you won't have access to that VM anymore. So this service was launched in 2019, so approximately 4 years ago. And one of the reasons for the high adoption of GitHub Actions is the marketplace. So the GitHub Actions Marketplace, you have apps and actions inside GitHub. The marketplace means that anyone here, even with a free GitHub account, can publish your own actions. So you can write your automation, and you can publish there to the marketplace so that other people could use. You can see that this number, 18,000, is probably higher today. It keeps changing every day, so I just gave up updating this slide. But basically, there is no verification, there is no security verification of the actions that are uploaded, that are offered inside the marketplace. Right? So yes, there are a lot of interesting things, so you don't reinvent the wheel. So if you need to build a JavaScript application, if you need to generate a container, it's probably already there, and it's beneficial for you, for developers. But what happens if a malicious user, an attacker, uploads something and tries to label, okay, this is legitimate, right? What happens there? And that's basically one of the main goals of my research that we're going to talk about today. But before we do that, how can you abuse GitHub Actions? Let's say you have free computing. You're not paying for that cloud service. You're not paying for that VM. Those runners there, they are run by Azure, by Microsoft. So you're not paying. It's free. Of course, on a limited time basis, but it's free. So the first thing that comes to mind, easy money for attackers, is mine cryptocurrency. Why can I not upload or deploy this action that would mine cryptocurrency for whatever hours I have available for free, right? So this is an example of a YAML file abusing Windows runners. So you can see here on line 6, deploying Windows latest. It means that this is the latest version of the GitHub action on Windows. And at the end here at the bottom, you see the node.exe file where it actually was inside the repo to mine the cryptocurrency. And they label node.exe, try to maybe mask that it's not a Monero crypto miner, but you can see that there. And some other things are happening, and I'll explain that on the other examples as well. But one thing here is really interesting on this specific one. Line 18 here, you see the uses, and this syntax uses means I'm calling a third-party action, right? So my action is calling another action. And it says nick-envision/retry at v2. Is Nick here? Please raise your hand, Nick? No? OK. So the problem is this is a legitimate action. This is an action that is used to retry your action if it fails. But attackers are already using third-party actions to automate their stuff. So they're using for malicious purposes. But it's a legitimate one. I have analyzed the code there. I checked for the retry action, and it says, okay, yeah, retries an action if it fails. There is nothing malicious there, but they're using that for their own gains. And of course, the node.exe file, it's not actually a node.exe, it's a crypto miner, and that was flagged by VirusTotal. It's probably more detections now, but okay, this is a problem. And what happens? This is a cat and mouse chase, basically with, excuse me, with GitHub and Microsoft, right? Because attackers, they keep creating other users and new repos and mining. So they're scaling their attacks because Microsoft, it's like a whack-a-mole, right? So, okay, you block one user, you block one repo, they just create another user, they just create another repo and start mining again, right? So this is a tough problem for them to solve, and I think they're still struggling with that, and we're gonna see that why in a second. Another example here, this is also abusing Windows Runner. It's running PowerShell. You can see if you know PowerShell, there are a few commands here on line 18, 20, and yeah, basically, and then running the crypto miner again. What's interesting about this one and is this matrix here. That's similar to what we saw on the previous one. This matrix means that I'm going to deploy different versions. Like if I have different versions of my application and I want to test it on different environment versions and I want to scale that, right? So I want to run those in parallel. But the idea here is to run different runners in parallel, right? Because, okay, I have more VMs running, I have more money, right? I get more money faster. Because if it gets flagged by Microsoft, by GitHub, then at least I made, I don't know, a few bucks. But yeah, same thing, downloading the crypto miner, the Monero there on line 18, expanding, and then running it again. And for whatever time it's available, if I'm not mistaken, each job has a limit of 6 hours, and each runner can run up to 72 hours. So that's like 3 days that they have this machine, and there is a specific configuration for each VMs that they can run and mine cryptocurrency for them. Okay, but like, why is this just one example? Is this just one user? No, we found more than 100 repos with the exact same code as this previous one. The exact same code. Just a few examples here, but there were 100 more with the exact same code, abusing crypto mining on GitHub Actions. Of course, we reported this to GitHub. It took them a few months to reply back to us. And I believe some of the repos are still up, but most of them have been taken down, or at least they have the action disabled. So what means is if you have the actions disabled, you can't run GitHub Actions. You can't deploy VMs on Azure anymore. But that's specific to that repo. That's not specific to the user. So if the user creates another repo, they can run GitHub Actions again. So it's like, okay, what is going on here?
It's funny, the first one also contained crypto and the YAML file.
Yeah. Sometimes they don't even try to hide, right? Sometimes they name it CI/CD, but sometimes, yeah, crypto stuff. So like, okay, and you can see a few of them have the same username, right? So it's like it's the same user creating and just creating different repos and trying to automate this stuff and scale. So similar example here. This is not specific to Windows, the ones that I provided earlier. Same thing. Here with Linux. And now I raise you the question, like if you're big into crypto, which is not my area of expertise, which one would be better to mine crypto, Windows or Linux, using CPU, not GPU? Anyone?
Generally, I would assume a Linux box.
Why?
Because there's less overhead.
Exactly, right? There is less bloatware, less stuff installed, less stuff running. So I asked a few friends about it, like, okay, what would be? Because they have the same exact configuration, memory and CPU, but why would you run it on Linux than Windows? Like, okay, yeah, that might be a reason. I'm not sure if that's the goal, but that's what I thought. Okay, that makes sense. But here, the same thing. they download from the crypto miner is even on GitHub, and it's like the legitimate crypto mining file, the crypto mining binary from XMRig, but they're just pointing for their username here, the pool, and start mining as long as they can. And if you're familiar, like if you use macOS and you think macOS is probably, how can I say, it's protected from malware, no, that's not the case. They're even leveraging macOS here, and this is a new thing. I presented this talk back at NDC Security in January. I don't know if someone was here, but this is a new thing. So we found this, someone now abusing macOS runners. So it's not specific to Windows, not specific to Linux, and they're trying to name it Core, Book, Hackintosh, whatever. And yes, I can't understand that, that's fine, but I can understand the YAML file. And if you look here, macOS latest, and basically what they're doing there, giving execute permissions and running XMRig, right? And the same file, the same XMRig no fee there, the binary, yeah, it's also malicious, detected by VirusTotal as a crypto miner. So this is happening, and this is what's going on. So if you ever go to a GitHub repo and you see this sign, this red sign, GitHub Actions is currently disabled for this repo, they probably did something wrong, right? So take a look at the YAML file. It's probably you can see the history there. So be aware of that. If you're going to maybe leverage some code from that repo, just be very careful. But as I said, this means that the GitHub Actions was blocked on that repo only, not the user. So if they create another repo, they can still use GitHub Actions. I'm not sure why, but that's how it is today. OK. See, doing time. OK, good. So one of the goals of my research, as I mentioned earlier, was marketplace. Anyone can post a GitHub Actions to the marketplace. There is no security verification. There is no validation by GitHub, no scanning, nothing on the security side. So what happens if someone uploads a malicious action to the marketplace and offer there, OK, yeah, this action will help you build your applications and generate a Docker container, whatever. It doesn't matter, right? So what happens there? One thing that I forgot to mention is that every GitHub action is a public repo. So it's a public repository. So you can read the code inside those actions. So if you see there on the right side, basically the two directives, uses actions/checkout and actions/setup-node, it means that if I go to the github.com/actions/checkout, I can see the exact code that is being downloaded inside my VM and being ran there. So I can read the code as well if I understand it, if I can analyze it as well. So one of the things that GitHub does to maybe do some validation there, and it's not great, it's the blue check mark. So this is not like the Twitter blue check mark. You don't pay to get it. But there is a creator verified by GitHub. It's basically a domain validation of the user or the company that is providing. You see that more frequently with companies that are offering their actions on the marketplace. But this one, actions, I know that this one is an organization or username provided by GitHub themselves. So GitHub security team or developer team, they work on these actions, and everything that is inside the actions user or organization is provided by them. So look for this check mark. It doesn't mean that it's being scanned by, for security, being validated. Just the creator has been verified. So it's not a great validation, but at least that's what we have right now. So once I was deploying these malicious actions, it's like, OK, I'm scanning the environment, right? I'm running a VM inside Azure. What can I do there? I'm exploring. So I was scanning the network, I was verifying tokens and things like that. So these are kind of the things that I did during the research. I was able to run an nmap. Nmap means network mapping, to map the ports and the services inside the network, inside the Azure internal network. So because the VM gets assigned to Azure, it's under a Microsoft-owned account or tenant, right? So, okay, maybe that can be a problem. One of the things that you can't do by default with your actions is run interactive commands. So if we're doing the pipeline as code approach, right, all the stuff that I want to do with my action has to be inside that YAML file, that automation. But what happens if I want to like a shell script, a prompt, and I want to interact with my action? Technically, you can't. But if you make your runner, your VM, connect back to a reverse shell to another machine that you control, then you can run interactive commands. And of course, if I'm deploying this VM and I have like sudo access to the sudo permissions to this VM, maybe can I do something like, would I be able to do something malicious and use this VM to attack other targets, attack other victims, even inside Azure or outside? Yes, that's possible too, right? So like I would be proxying my attacks to this VM and trying to hide the origin of the attack. Of course, there's ways for Microsoft to track you down, but that would be a way to avoid some of the detection. So here's just an nmap scan. The kind of default ports 22, 80, 443, 3389. But there is one that's interesting here, the 8084. So this is a web service called Mono XSP. Has anyone heard of Mono XSP? Okay, no. See? It's a very old web server that was, was running on Linux, but it was developed in ASP or .NET and was ported to Linux. And this web server caught my attention because it was enabled by default. Different from Apache or Nginx, it was already enabled by default. So why do you have this web server on my runner that it's enabled by default? That's basically, and it got removed now, but basically it was, I couldn't figure out the idea behind this Mono XSP. We did some research, we analyzed the code as well, but it seems there was some health or administration features used by Azure themselves, but they removed. In the latest version of the Ubuntu VM, the actions, it's not there anymore. So maybe they found something that it wasn't good. Okay, so on the top here, this is the reverse shell from the runner. So on the top here, I'm basically downloading Netcat. It's a tool can use it for network assessment validations, but I can also use as a backdoor. And I deployed an instance on AWS, an EC2 instance. You can see by the username here. And I made my runner connect back to this machine. So installing Netcat inside the YAML, this is the YAML file, configure, and then the IP address. I was able to get access to my Linux Azure VM here. So now I can send interactive commands. There is the username. It's running as a runner. So I can play around with it. So I don't need to keep changing the YAML files all the time and then waiting for it to, assign another runner. So I can play more with it. Since I can do reverse shells from the runners, right, I can also issue malicious commands. I can tell it to attack someone else, either inside Azure or outside of Azure. So that's interesting. But we haven't done the malicious GitHub Actions yet. Where is that? Okay. what happens if I pack this YAML file as action and publish that to the marketplace. And then anybody that runs it, it would connect back to my command and control server, my machine here that's running on Azure. Okay, let's try that. And that's what I did. Basically, of course, I didn't publish on the marketplace for legal reasons, otherwise I wouldn't be here today. but yeah, the idea was basically a shell script that would call that command. So just same thing, downloading netcat, installing, and calling my C2 environment. So what happens, what I did was, from one repo, separate repo, calling this action. So how do you call third-party actions? The uses directive, right? So that's what I did. Okay. So you can see here that this is another repo, another place, and I'm calling the third-party action, Magno Logan fake GHA. So this is another one. So this would be like, okay, if I posted this on the marketplace, this is what you call, right? Of course, I made it in a way that it's, okay, you can see that it's not legitimate. It's not, like I'm not trying to mask it or anything. But I got the same thing. I got the shell back to, from the runner. So now what that means is, if I publish this to the marketplace, anyone that uses, and of course I would mask it as something legitimate, but anyone that uses my action, they add this to the YAML file, it would create a backdoor to their environment. So I would be able to compromise their environment, get tokens, do whatever. I can run interactive commands if I wanted to. So I would be able to do that. Of course, I didn't do it, but yeah, that's a possibility. I validated that. Okay, so to wrap up before we move on, let's understand some countermeasures. How can I protect myself if I'm just using GitHub Actions in my CI/CD pipeline? I have my automation there. What are some things that I need to consider and be aware of? So I know this is not a great advice, but this is what we have right now. Only use actions from trusted creators. If you're using actions from non-trusted creators, try to at least review the code, understand what you're doing. Don't consider that because they're going to have access to your repo. There's some tokens involved, some credentials as well, which I couldn't cover everything here, but be aware of that. Look for, if there's, usually you might find two similar actions, one from trusted and one from untrusted. So pick the trusted one. That's my recommendation. Make sure you set the right permissions for your tokens, for your actions. So technically, by default, actions have a token, GitHub token, which before had read and write permissions to your repo. So one action, your VM was running here, and it was able to modify stuff on your repository. Now, I think GitHub changed that to read only, which is better, but yeah. So assume the least privilege principle, where you only apply the necessary privileges to this token, to this credential. Another thing is, don't run actions from forked repos. So this was a problem that was before when GitHub Actions was launched. Now, technically, it's fixed. But the problem was that when you forked a repo and you modify the action file, the YAML file, when you sent the pull request back to the original one, your action would run. So people were mining cryptocurrencies in the name of the other users. So people were forking a bunch of repos and changing the YAML file, exactly what we saw, to mine cryptocurrencies in the name of other users. And of course, protect your secrets and verify untrusted inputs. So there is some fields on the GitHub Actions that can be considered untrusted, and so you need to validate those as well. So the last two things here on the GitHub Actions, if you're not using actions, disable it, right? So you can go to either by repository or for the entire organization, you disable actions. But if you are using, you can specify, you can reduce the blast radius of the impact of someone compromising your actions. And this is the setting that's enabled by default now, the GitHub change, to avoid anyone from forking your repo and then sending a pull request back to modify your actions as well. And just to wrap up, I will give the floor to Nitesh to give his recommendations around Codespaces.
Thank you, Magno. So for Codespaces, the abuse is very straightforward because you get a virtual machine for free on Azure, and you can create automations using dev containers. So one of the cool things that InfoSec people talk about is trust but verify. Like, trusting is fine, but you need to verify the extensions, the container images, the command directives like post start command, post create command, initialize command, and the different features that are being used in your dev container configurations. Because let's say if we talk about the container images, threat actors have been observed to create similar sounding container images on Docker Hub, and then when you just do a typo or something, you download the wrong image instead of the legitimate one. You need to have container scanning solutions or secret scanning solutions in your workflow to avoid committing credentials, maybe publicly, because it's very trivial to, like we saw in the POC for Codespaces, it is very trivial to create Codespaces just by a valid token that you may have that belongs to some other user. If you're using authentication tokens in your workflows, make sure that the scope and the permissions that you assign to the token are very limited. Because there was a case that was reported to HackerOne. This was found on GitHub Codespaces. And there it was found that on every Codespace that you create, there was a personal access token, the Docker Hub personal access token of a GitHub developer on every Codespace. So while looking for the permissions that were assigned to the personal access token, the permissions were like just public read. So it was not very dangerous at all. But that was a good story. Even if you leak your tokens, it does not do a lot of damage. Auditing Codespace and access token usage. So for the Codespaces that you create, delete, suspend, assign permissions, I mean the tokens that are generated for your Codespace, there are logs generated on the GitHub settings. So you can take a look into those, and if you are on GitHub Enterprise, then you can query them using the API as well. And yeah, so like we saw, any Codespace port URL, it cannot be trusted at the first shot. Because let's say if a friend of yours is saying, hey, I just made this cool website, why don't you just take a look at it? Here's the Codespace URL. If you just open it, there may be chances that your browser is outdated. There is a 0-day in the published port itself. You may get compromised. Like, that's a very extreme level of compromise, but that is still possible. So you need to segregate your developer and production environments. So for example, if your Linux server that is, let's say an EC2 instance, it's a production server, it should not be accessing Codespaces URL because Codespaces is a development environment. So you need to segregate between these two, and like it depends on the context as well, but yeah. So that's it for Codespaces and GitHub Actions. We are happy to take any questions if you may have.
Yep. Thanks, everyone. Thank you.